In the last skill refresher set, we learned about the distributive property. We got some practice using the distributive property. And now we're going to factor. We're going to factor polynomials. In particular, we're going to focus on factoring quadratics, but some of them may not be completely quadratic. But we're going to work on the skill of factoring in this next skill refresher set. So the first thing we're going to do is just look at factoring out the greatest common factor. All right, so what we want to do is we're going to use the distributive property in reverse. All right, so we want to look at the two terms in this expression and find all of the factors that the two terms have in common. All right, so now I could write this out into its prime factors. This is 2 times x times x, right? And then this is minus 2 times 3 times x. All right, so I could write that all out, and then you could identify that, okay, both of those terms have a factor of 2, and they both have a factor of x. All right, oops, x, right? So if we factor out a 2x, right, then we're left in parentheses. What we're left with is what we, whatever we didn't factor out. So if we factor out a 2x, then we're left with 2x inside the parentheses, and then over here we've got a minus 3. All right. Now you can always check your work, because if I use the distributive property on this new expression, it should be the same as what we had in the first place, right? So if I distribute the 2x across this binomial, I'll end up with 4x squared minus 6x, which is what we started with. So these two expressions are equivalent to each other. All right, so we're just looking for the greatest common factor between the two terms, or the terms of the expression, and trying to factor them out. All right, so now you don't always have to write out all the factors in prime factor form. In fact, you probably usually will not do that, but I'll do that for the first couple here. So x cubed is x times x times x, and then minus x times x, right? So we have two terms, and you can see that they there's a common factor of x times x, right? So I'm going to factor out an x squared, and then see what I have left after I factor that out, right? If I factor out an x squared, then I'm left with the first term just becomes x. And then now this is a little bit tricky. You've gotta remember that this could be written as 1 times x, and so what I have left after I factor out an x squared is just a minus 1. All right, you could think of, I could divide each one of these terms by x squared to see what's left. And so if I divide a negative x squared by x squared, I get a negative 1. All right, now remember, again, you can check. If I redistribute the x squared, I should get what I started with. And you can see that I will. If I take x squared times x, I get x cubed. X squared times minus 1 is x squared. So, or the minus x squared. All right, so let's do a couple more examples here. Here, this looks a little different, right? It looks a little different, but we actually have two terms here. There's two terms. This is a term, this is a term, right? Those are things that are multiplied together, even though one of those terms is a binomial. It's x minus 2. That's still, it's still a factor, right? X minus 2 is a factor of the first term. And I see that both of those terms have a factor of x minus 2, so let's factor that out. I'm going to take x minus 2 and I'm going to factor it out of that expression and then see what's left. So if I take x squared and factor out, x squared times the quantity x minus 2, I factor out the x minus 2, I'm just left with x squared. And then here I'm just going to be left with a 5. Okay? So this looks a little different, but it's really critical to understand what a term is and what a factor is. All right, so it looks a little different with, you have a factor here that is actually a binomial, but it's still a factor. All right, so we're factoring out the x minus 2, and then what we're left with is x squared minus 5. All right, so again, you should be able to redistribute the x minus 2 and get what you started with, right? So All right, let's take a look at the next one. Now here we have, we have variable x, and then we also have this a, which often represents an arbitrary constant, not necessarily a variable, but it could be considered a variable. But let's go ahead and write this out. We have 2 times a times x, and then 14 is 2 times 7 times a times a. So we have in each of these terms, we have a factor of 2 and a factor of x. Factor of 2. Oh, no, we don't have a factor of x in that last one. Right, okay, so, whoops, didn't mean to erase the whole thing. We have a factor of a, right? We have a factor of a, right? So each one of those terms has a factor of 2 and a factor of a, right? So that's the greatest common factor of the two terms. So I'm going to factor out a 2a, and then see what I have left, right? So I factor out the 2a, I'm left with an x. And then in the second term, I'm left with 7a. All right, so now I've factored that expression. All right, so practice doing that with these next problems, and I'll see you in the next video.